All right, folks, we've got a pretty big topic on our hands tonight. This is the topic of continuity. You need to take your time and take excellent notes. Our notation is going to be so important here. Make sure that limit appears in every step of the way. So, continuity is such a wonderful idea, the definition of continuity. And of course, continuity just stems from the word continuous. So, if you think about just a basic bridge example, I would say this first example is a picture of a bridge that is continuous. Okay, I can get from point A to point B, and I won't fall off the bridge. I can easily walk across this bridge. It is one continuous bridge. However, if you look at my second picture, I would say this is discontinuous. All right, I can't get from point A to point B without falling off the bridge. If I start walking, I'll eventually fall down this hole. So this is discontinuous. Also, we could say it has a discontinuity. And that's as simple as I want you to think of continuous versus discontinuous, or continuity and discontinuity. So we're basically saying for a function to be continuous, it can have no holes, breakpoints, so let me be clear about my holes. I can't have a big hole in the graph. I can't have a breakpoint where I start here, I pick up down here. Let's see, and lastly, specifically a vertical asymptote. Okay, I can't be on this side and then magically get to this side, so no vertical asymptotes. Now, however, I notice I didn't say just general asymptotes. It can have a horizontal. Okay, I can have a horizontal asymptote and be continuous. Think about this picture. And we'll draw in a nice horizontal. Can I get from point A to point B and have a horizontal asymptote in my picture? Of course, there's nothing wrong with that. You just can't have a vertical asymptote. So take some time and sketch this function. Obviously pause it and sketch this in your notebook. And our question is, when you're ready, given the graph of f of x, state the intervals on which the function is continuous. So I'm basically going to say I am continuous from this point, which is -7, up until -3. Okay, notice I have a bracket for a closed circle, a nice parenthesis for an open circle. Okay, then there's this breakpoint. Okay, right here I've got a breakpoint. It jumps, so to speak. So I can pick it back up from -3, and I would say it's continuous until, notice there's a hole in the graph, until I get to the point 2. And then I can pick it back up at 2 and go to 3. Okay, so I'm continuous on that line, that section there, from here to here, and then I'm picking it back up at 2 for this section. Then I would say I'm continuous from, there's an open hole, so from 3 to 6, is that 6? Okay, asymptotes don't get brackets either. And then again from 6 to, let's say, 8, because there's a hole. And then from 8 to infinity. Okay, notice I'm not continuous at that point that's sitting there. I don't need to worry about a point. So how do you determine if a function is continuous? Well, we have this great little saying called the three-headed monster. And it's very simple. Basically, and let's box this in our notebook. This is huge. This is one of our big definitions. Our definition of continuity, or continuous. Don't let those words trip you up. The limit as x approaches a from the left of f of x has to equal the limit as x approaches a from the right side of f of x. Okay, so think about what I'm saying. If the left side and the right side are equal, I'm saying the limit exists, and then that just has to equal f of a. Okay, so I'm looking for 3 things. This is going to be a common bite-sized question. All right, I'm looking for these 3 things, the three-headed monster. The limit from the left has to equal the limit from the right, has to equal f of that number. And I'm telling you, this makes perfect sense. Think about this. If here's a, as I approach a from the left and I approach a from the right, all I'm saying is the limit exists. That's what these two are saying together. And to be continuous, remember, I can't have a hole in my bridge. I need f of a to be that same value. Basically, I need this to be a closed circle. And that's what this is saying. At a, that a number we're using, we're filling it in. So we'll run through a few common examples. And like I said, this is a pretty big topic for us. The left side has to equal the right side, has to equal that function. Now, some people, they like to kind of condense that one side, which is fine. When I say the left side equals the right side, I'm really saying that the general limit as x approaches a exists, and it's equal to f of a. Okay, but in theory, this is saying the left side equals the right side equals f of a. Alright, so here's a typical AP question. Is the function continuous at its breakpoints? So first of all, what are the breakpoints? And hopefully you've already decided that they are -1 and 6. So I basically have to do two problems, one for -1 and one for 6, and we'll just take one at a time. So the word continuous, box that in, that's what gives it away. There's your three-headed monster. That's what I'm going to write out. The limit as x approaches -1 from the left of f of x has to equal the limit as x approaches -1 from the right side of f of x, and that has to equal f of -1. And all you do is you write that out and you evaluate it, and it's so easy. So the limit from the left has to equal the limit from the right, has to equal f of that value. All right, so now let's plug them in and watch the magic happen. -1 from the left, so obviously it's this function or this function that deal with -1. And if I'm coming in from the left, that's this top function. Now again, hopefully your gut is saying I can clean that up quite a bit. So I'm going to take that 2 and factor it out. I get x plus 3. On the bottom, I get x plus 3 and x minus 3. A little sloppy there. So I think I've got 2 over x minus 3. So I'm just going to write that, I guess, down here. 2 over x minus 3. And I'm plugging in the point -1. So I've got 2 over -4 or -1/2. And my goal is that equal to the rest of this stuff? Alright, so now let's take -1 from the right side, which is this function. And again, I'm going to clean it up. I'm going to pull out a 2, and I'm left with x minus 3 over x minus 4. Nothing cancels. So I'm going to plug in my -1. Oh, I get, let's see, -2 minus 6 is -8, all over -5, which turns out to be an 8/5. Now, does the limit exist? Does the left side equal the right side? And my answer is no. I technically don't have to go any further. This function is not continuous. And again, what I'm implying is that this is at -1, this is approaching a height of -1/2, and this side's approaching 8/5. It has no chance of being continuous if the left and the right don't even equal each other. But I will go further just to, finish my problem here. F of -1 is when it's equal to -1, which is this guy, and we already know our answer is -8/5. But since the left and the right and the f of value don't equal, all I'm going to say is this function is not continuous. And it's that simple. Okay? Three-headed monster every time we see that word continuity. We have one more point to check, and that was, I believe the other breakpoint was x equals 6. So I pulled it back up, and we're going to do the same thing. Because we saw that word continuity, we're doing our three-headed monster. The limit as x approaches 6 from the left side of f of x has to equal the limit as x approaches 6 from the right side of f of x has to equal f of 6. Alright, and we're just going to test all three. So 6's are dealing with these two. The left side is this guy, and we're going to carefully plug in 6. 2 times 6 is 12, minus 6 is 6, and then 6 minus 4 is 2, so I get an answer of 3. 6 from the right would be this side. I get the square root of 6 plus 3, the square root of 9 is 3. And f of 6, which one of these has the equal sign, that's this guy here, is also 3. So now I can say my function is continuous. Okay, the left has to equal the right, has to equal f of. Next question, determine if g is continuous or not at x equals 1. Justify your answer. Well, again, the second you see that word continuous, you're in great shape. Three-headed monster, write it out. The limit as x approaches 1, now don't say f of x this time, they told you it was of g of x. They will take off a point, oops, from the left, equals the limit as x approaches 1 from the right of g of x, has to equal g of what number did we care about? G of 1. Okay, and again, it's whatever that breakpoint is typically. And they did tell us right there. All right, now, just be real careful with your math. The less than 1 from the left is going to be this top one, of course. I'm just going to substitute 1 in. The ln of 1 plus the cosine of 0. All right, we all know what that ln graph looks like. There's only a couple points you need to know, and the ln of 1 is an answer there. The ln of 1 is 0. And the cosine of 0, picture that cosine graph. The cosine of 0 is 1, so I would say that answer is 1. The limit from the right, I'm going to get e to the 1 minus 1, so e to the 0, plus 2 sine of 1 times pi is pi. All right, any term to the 0 power is 1 plus 2 times the sine of pi. Picture that sine graph. The sine of pi is 0, so I get 1 equals 1. All right, and right here, that just tells me that the limit exists. And now I have to evaluate g of 1. Do either of those include 1? Well, that first one does, and we already know its answer is 1. So I would say, yes, it's continuous, and all of this work is your justification. You don't need a fancy sentence. This work is good enough, especially this line is what we're looking for. All right, the AP loves this problem, and it's not any harder than the last two problems. It just kind of messes with some students' minds. Notice they don't have a less than or greater than. They basically say does not equals to or equals to. So unless you are the exact number 2, you're going to use this for everything else. So I'm going to set up my problem. The limit, it says continuous of course, as x approaches 2 from the left, watch your function, of h of x, equals the limit as x approaches 2 from the right of h of x, of course, equals h of 2. Now I'm going to do the easiest one right off the bat. H of 2, they're telling me right here, h of 2 is 3. Okay, now I just got to carefully evaluate those other terms. Basically, if I'm coming in 2 from the left, pick a number that's to the left of 2, like 1.99999. Unless I said the number 2 itself, I'm using this top equation. So x squared minus 8x plus 12 all over 4 minus x squared. Now remember, factor first there. So I'm going to say this is 2 minus x, 2 plus x on the bottom. And on top, probably 6 and 2, x minus 6 and x minus 2. Those cancel to a negative. So if I carefully plug in my 2 now, I've got 2 minus 6, which is negative 4, and that negative on top makes it a positive 4. And 2 plus 2 is 4. I get a nice 1 there. Hopefully you do as well. Again, if I'm going too fast, you've got to slow down and pause it and do it on your own. Make sure this is worthwhile. Now it says 2 from the right, so pick a number to the right of 2, like 2.0001. Okay? Which equation would you use? Are you exactly 2, or are you not exactly the number 2? Well, clearly I'm not. I'm a little bigger than 2. I'm to the right of 2. So I'm using that same equation, which I've already factored and said it's the x minus 6, and I had a negative 1 on top, all over 2 plus x. And I'm carefully plugging in a 2, and I should get the same answer, of course, which is equal to 1, and does that equal 3? Okay, so at this point, I can say the limit exists because the left side was equal to the right side, but this function is not continuous. Okay, so what does that look like graphically? Well, as you come in from the left and you come in from the right, they're meeting at a height of 1, but the actual closed value is at a height of 3. All right, now comes the fun algebra. Again, a very typical question on our exam. Find the value of a so that the function is continuous. So this word continuous is not going to go away all year. And in order to be continuous, the left side and the right side have to equal, and that point has to exist. So I'm going to start with just the two pieces. The limit as x approaches, here's the number I care about, my breakpoint, -2 from the left of h of x has to equal the limit as x approaches -2 from the right side of h of x. Okay, first my limit has to exist before I can even figure out what that point is. All right, I got to show this limit exists first. So all I'm going to do is set those two equations equal. 2x squared minus a equals ax cubed plus 3x. It's that simple. Set the equations equal. Now, you're finding a, which means you better know what x is. And we just circled it. They only care about this when the x value is approaching -2. So I'm going to replace all my x's with -2. Clean it up. -2 squared is 4 times 2, so I've got 8 minus a equals -8a minus 6. And now it's simple. Just solve for a. I'm going to add my 8a and subtract my 8. So what does that give me? 7a equals -14. A equals -2. And there you go. So the left side has to equal the right side. And that's how I'm starting these problems off. All right, this is the last problem for the night, but it's not an easy one. This is a nice big bear that we're going to tackle here. So the question says find the values of b and c. So since they gave you two variables, b and c, there's probably two breakpoints. And as you can tell, just staring at it, you do have two breakpoints you have to consider. You have to consider -2 and 3. So I'm going to write two equations, one for -2 and one for 3. The limit as x approaches -2 from the left of f of x has to equal the limit as x approaches -2 from the right side of f of x. And I'm going to try to break it up because it's going to get a little messy. I'm going to write one for 3 as well. The limit as x approaches 3 from the right side of f of x has to equal the limit as x approaches 3 from the left side of f of x. Alright, so all I'm doing is I'm taking the ones that involve -2 and I'm just setting those two terms equal. So cx plus 3b equals bx squared minus 4. Simple enough. Left side equals right side. What number can you plug into x at this point? Well, we said as x approaches 2, -2. So I've got -2c plus 3b. -2 squared is 4b minus 4. The only thing I can really put together are the b's. So I'm going to say -2c equals, if I subtract 3b, I'm going to get b minus 4. And I'm just going to kind of leave it like that for the time being. I can't really go any further. I could solve for b, I could solve for c. I don't know which one I want, so I'm going to stop there. And I'm going to go work on the other problem. I'm going to, set these two terms equal, the ones with the 3's. So I'm going to say bx squared minus 4 equals cx cubed minus bx. And don't forget, you know the x value. The x value in this problem was 3. I've got 9b minus 4. 3 cubed is 27c minus 3b. And again, I can put my b's together, so that looks like, I'm going to bring this -3 over. 12b minus 4 equals 27c. Okay? Now, basically, I am going to use substitution to solve this problem. Notice I didn't solve either equation for b or c. I wasn't exactly sure what I wanted. But if I were to look at this, would it be easier to get c by itself or easier to get b by itself? On this side, I'm saying b would be a lot easier. If I look at this equation, they're both going to be ugly. They're going to involve fractions that I don't really want to deal with at the moment, so I'm not going to solve that one. I'm going to say this one's easier. I'm going to say b is equal to -2c plus 4. Now that I know what b is from this equation, I'm going to substitute it into the b in this equation. So I'm going to say 12 times -2c plus 4 minus 4 equals 27c. And I'm just going to clean it up a little, so that's -24c plus 48 minus 4 equals 27c. 48 minus 4 gets me a 44. I'm going to add that 24c over. So I think that's 51c. So I can say c is equal to 44 over 51. Not a pretty number, most likely won't be, and there we go. Now that we know what C is, we can easily go get B. I'm just going to take that C and plug it back into this equation. So B equals negative 2 times 44 over 51 plus 4. So B equals negative 88 over 51 plus 4. Remember, that's negative 2 over 1. And I'm going to quickly get myself a common denominator. Let's see, I'm going to say I can multiply the top and bottom by 51. So that's negative 88 plus 204, all over common denominator of 51. So B equals, what's that, negative 116 over 51. Again, not the prettiest, not the ugliest, but very manageable. So however many breakpoints are, that's how many equations you're going to have. Remember continuity, the left has to equal the right, and you're good to go. Have a great night, and we'll see you tomorrow.